So hi everyone, welcome to the demo session of ThreeFold. This week we will discuss about artificial intelligence and machine learning. So I think personally that it will be a nice demo, and I can't wait to see what Scott has to show us. So just to show you a little bit of the agenda for today. First, just a reminder that there is a guide right now on the manual. You can see the link here. So if you want to explore the basic AI and GPU deployment, have a go. And then we will start the demo with a short presentation on AI and ML, so machine learning and artificial intelligence. And then once we have this presentation done, Scott will make a short demo on how to use Llama. And then afterwards, we will have an open section for you guys if you have any questions.
All right. Thanks, Mik. I'm going to jump in here and just say a little bit about AI and LLM chatbots. I think these days everyone is familiar with ChatGPT, which is the sort of predominant leading LLM, large language model, that has popularized the idea of an AI that you can chat with and sort of have a conversation, which is something people have been thinking about for a long time. But despite the name OpenAI, ChatGPT algorithm is proprietary. I think maybe they've started to release some of the older versions, but the latest versions are proprietary. And the bleeding edge of AI research is done in sort of these large specialized data center kind of compute appliances, let's say. So these are built specifically for the job that they do, and they'd be very complicated and expensive to reproduce. So we're not going to try to recreate what OpenAI is doing at the bleeding edge of AI research today, but we can do pretty good with open source models and the commodity hardware that we have available on the grid. We're not going to be training any models from scratch today. I mean, you can do things like that, but today we'll just be taking an existing model, seeing how we can deploy it and run it just with CPUs on the ThreeFold grid. So some definitions here: artificial intelligence and machine learning. These are just basically various technologies and techniques to try to make computers smarter and exhibit human-like intelligence. And the sort of first major example we have of AI sort of getting as smart or smarter than humans is in the game of chess. So over here on the right, I have an image of Garry Kasparov, the chess grandmaster, #1 chess player in the world at the time in 1997, in the second match they had with an AI developed by IBM called Deep Blue, and Deep Blue won. So since this time, basically, computers have been better than humans at playing chess according to standard sort of rules and setup that we have. And now if you're looking at the best chess in the world, it's all about computers playing against computers. I mean, humans are still playing chess, of course, but as of this time, we have AI doing a complicated thing better than humans. And since then, we now have machine learning translation in the form of Google Translate that is extremely good. You can travel over the world and actually communicate with people just using your phone, and that's very cool. Now we also have these large language model chatbots and also image generation that is kind of swept through, and you see this stuff everywhere now. So what are LLMs, large language models? These are just a specific type of AI model that focuses on processing and generating large amounts of language data. Usually this data is taken from the internet and other sources, and LLMs are good at having natural conversations, summarizing text, answering questions, and they're also getting pretty good at writing code and helping developers write code. So now, since Deep Blue and Garry Kasparov, now we are moving on to fulfilling the true purpose of the internet, which is generating and sharing pictures of cats, especially cats in outer space. So this is an example of an image I generated with a free AI tool in about 5 minutes while I was making the slides, and just shows you an example of what you can do these days. I'm sure everyone has seen stuff like this. And let's move this over here so we can see all the text. And just a couple more definitions. So an AI model is a specific AI algorithm, and these generally progress in generations. So ChatGPT, you have GPT-3, GPT-4. There's Gemini from Google, that's another model, and Midjourney is a graphics model that maybe some of you heard of, and Midjourney has V4, V5, I think they're out with now. And every generation of these models become bigger and more complex. We also have a concept of weights. So the model is sort of the base of the algorithm, and the weights are the data. These are interchangeable data sets for a given model, and these are essential to the function. So in order to have a working LLM or AI in this form, you need both the model and the weights. And the weights can be interchanged to specialize the model for different tasks. So this is especially seen with coding. You'll have like a weight set for coding. And they come in different sizes, 8 billion, 70 billion. These are common parameter sizes. And the parameters also can have different quantization levels. That's the amount of detail that's in there as well. So these are some things that we'll be seeing in the demo today, are the weights that we'll be pulling in for the model. So AI workloads on decentralized servers like the ThreeFold grid. So why would we want to do this? There's a few reasons. A big one is for data security and transparency. So again, like ChatGPT and other proprietary models are operated in a sort of black box, centralized fashion, and you can't really be sure what's happening with any data that you supply to those models, including the questions that you're asking, and potentially any personal data that you might want the AI to operate on. We also have possibility of increased scalability, and as we're seeing today, like creating and training these models can be rather difficult and require a lot of hardware, but actually running a model can be done on a relatively small scale. So this allows the models to be run all over the world, and also closer to where the work needs to be done. So as we'll see, even with a fair amount of compute, doing this work can still take some time. So if you have a latency sensitive application, AI models are already relatively slow unless they're running on very powerful hardware. So putting them closer to where the tasks they're doing are can be an advantage. And also just autonomy and self-sovereignty, basically having control over knowing what we're doing. We're working with open source code. The ThreeFold grid is entirely open source. So this just gives a better level of sort of understanding about what you're actually working with versus black box, centralized AI services, or even running open source models on centralized clouds. So all this together means, with a demo like I'm showing today, you have a better sense of what you're working with, what's happening with your data. And I think this opens a door to being able to use these AI tools to process data that you might not be comfortable handing over to like a ChatGPT. Especially if you're deploying to like a farm with farmer that you trust, or maybe using some kind of encryption. I won't be showing encryption today, but that's another ingredient you could put in the mix here to have actually pretty good control over the data and be able to get AI capabilities with your local data and maybe have more relevant results. So those are some possibilities anyway. And today we'll be working with Llama. Llama is an AI model developed by Meta, aka Facebook, and it's been open source. So that might be somewhat surprising coming from Meta, but they are actually the leaders in releasing AI model is open source. So Llama is free to use and also to customize. In addition to the Llama model, there's also a large library of freely available weights for Llama, which we'll be seeing later. Llama is designed to be more conversational, especially with Llama 3. It's people report that it's like nice to talk to and have conversations with. It's been trained on a massive data set of text from the internet, and it can generate responses on a wide range of topics and questions. We'll see a little bit about that later. And specifically today, we'll be working with Llama, which is a sort of convenient packaging of the Llama model, and Llama also provides a library of openly available weights. I'll be showing you that. And then in front of Llama, we'll be using the Open WebUI, which is one of many, many front ends for Llama that provides a nice, convenient user interface. It also helps us to load in the weights and gives us a way to chat with the bot. But I'll just emphasize that there are many, many other tools out there. We're definitely in some kind of like AI boom if you go and look at all the different projects that are out there and coming every day. So this is just one of many, but it's the one that I found in my research to be the simplest to deploy and the nicest to look at and work with. And it's a fairly popular one, but if you're curious, there's a lot to go and explore out there. All right, so with that, let's get into the demo. There's one more slide here. So demo time, yeah. Here is the ThreeFold dashboard, and this is where we are starting our demos. So I've already logged in here. I have some TFT in my account. We get mainnet, and I've selected the virtual machines tab over here on the left. In this case, I'm going to take a full virtual machine. The reason for this in the demo today is mainly that the full VM is the simplest way to get a well-performing Docker setup. It's also possible to do this in a micro VM, but just takes a couple extra steps. So this will help simplify things for us today. I'm going to click first on the large capacity size here, and then I'm actually going to customize from there and use 16 CPU cores and 16 gigabytes of RAM. The model that we're running today doesn't require a ton of RAM. I think 16 gigabytes is maybe more than we actually need, but VM will be able to use this for some caching and stuff. So 16 cores is a lot, and we don't need that many. Again, we don't need a VM this big to run the model, but it will help us with performance and have things be a bit snappier. So you can run this with less and it will cost less, but it will just take more time. So that's kind of the trade-off. 16 cores I find to be pretty good performance for a nice demo. As far as networking goes, I'm going to disable all options except WireGuard. The reason here is that the web interface will be, there is authentication in the web interface, but I just prefer not to expose it on any public networks, including even my Silverman planetary network. And there's a large chance of getting attacked there, but especially like if you assign a public IP to this workload, like probably some bots are going to be scanning it and trying to get in. So for our purposes of like a single user setup or even something that maybe you want to share with friends, WireGuard is a great choice. It's going to give us a layer of security in front of the authentication, the login system for the web service. All right, so let's just review Ubuntu VM, 16 cores. We don't need this much disk, but that's fine. And I'm not going to be doing anything with GPU today, so I think later we'll show a GPU example, and GPU can definitely help both with running a model and processing prompts like we're doing today, and also with training models, but it's a bit more complicated to get set up with GPU. So I'm just going to select a node here. In this case, select a node that has some available cores and RAM and deploy. So this will take a moment to deploy.
Maybe in the meantime, Robert has a question in the chat. when you talked about using WireGuard, he's asking, what about mycelium? Would that be exposed?
Yeah, so if you run a service on Mycelium, anyone that is part of the Mycelium network can access it. And it's possible to discover other participants in the Mycelium networks. I mean, there's some degree of like security by obscurity just because not that many people are using Mycelium. And all the communication on Mycelium is end-to-end encrypted. But if you host a website or web service on Mycelium, anyone's part of Mycelium network, as long as they have that address or they can discover that address, they can connect to your service and try to hack into it. So it is possible to create private Mycelium networks. It's not something that's directly supported in the grid front end right now, but it's something to be aware of. And that's also the case with Yggdrasil. These are ultimately public networks. All right, so our deployment is finished. I'm going to come in here. I'm going to copy the WireGuard config. And over here in my terminal, I'm just going to write this WireGuard config into a file. You could do this with a text editor. I'm just doing it here on the command line quickly. I'm going to use WireGuard quick up to connect to this WireGuard network. And I'm going to copy the WireGuard IP here and SSH to this IP. All right, so now we're here inside of our Ubuntu VM. Clear the screen. Next thing I'm going to do is install Docker. So you can do this from the official Ubuntu repositories. I prefer to use the install script from Docker. It's at get.docker.com and just run the script like this. This is going to install the latest version of Docker from Docker's repositories. It's the way that I prefer to do it. That's going to take a minute. So while that's working, let's go and just check out a bit about Ollama. Ollama is here at ollama.com, and it allows you to get up and running with a number of models. Llama, Phi, Mistral, Gemma, and some others. So I mentioned Llama before. There's actually other models that you can run here. Gemma, I think, is based on it's part of the Google Gemini project. And Mistral is another model that's popular and has good performance. I think some of these might be derived from Llama or otherwise related. But when we come in here, the sort of most interesting part is the models library. And this shows us the different models. These are some featured models. We can also look at popular models, and we'll see things like Code Gemma. So this is a model that's specifically a version of Gemma that's specifically for coding, like I was mentioning earlier. And there's quite a few. So in this case, I'm going to be showing Llama 3, which is the latest version of Llama, generally considered to be the best performing open source, freely available model that's out there today. If I click, it will take just a minute to load. And then we can see in here, so I was mentioning weights earlier, we can, here in the dropdown, we can check different weights. There's instruct, which is normally what we're wanting, like in a conversational setting. The instruct is the one that's going to answer questions. Text is more about just sort of predicting what should come next in that flow of text. And we can see that there are different weights, like the 70 billion token weight with quantization level of 8 bits here is 75 gigabytes, which is quite large. The base model is going to be 8 billion tokens at a 4-bit quantization level, which is only 4.7 gigabytes, which is much more reasonable. And the front end, like I mentioned earlier, is WebUI. That's over here. So WebUI is here on GitHub. And if we scroll down, What I'm going to be using today is OpenWebUI with bundled Llama support. So this is a single Docker container that contains the UI and also contains Llama. This is the single Docker command that you can use to run it. And there's some other ways to run OpenWebUI. You can use Llama in a separate container and some things like that, but we'll be using a quick and easy way to get started today. We'll be using the bundled container and just a single Docker command. There's also Docker compose files and things like that if you are into that. So this image is fairly large, about a gigabyte. While that's downloading, we can just check out some of the features here that are in OpenWebUI. Easy to set up. We already saw that part. It's got Llama. It also integrates with OpenAI, so you can plug this in also to like ChatGPT and have your self-hosted models and your OpenAI proprietary models in one interface. We'll be showing the proprietary piece today, but it's there. They have some cool stuff around like pipelines and plugins. I haven't played with this yet, but there's apparently like a plugin that can give you live translation out of your conversations with the model. It supports Markdown, which is cool. You can actually, we'll see it typing in Markdown. We can give you Markdown formatted output, which we love at ThreeFold Markdown. And there's some tools around, like if you have more advanced use cases for building models and inserting Python functions, you can do stuff like that. It has a web search feature, which allows it to use a number of search engines to get like live data from the web. I did test that. I found it to be rather slow, but it's there. You can also feed in URLs and it will grab the website and use that as live input. It also has the ability to scan local document libraries. That's here, I think. This, I call it RAG. So you can give it a set of documents to scan over, and then you can ask questions about it, PDFs, personal documents, things like that. So that's kind of cool, and that's again a sort of major use case for this sort of thing is if you're comfortable with the environment that you're in, you might be more comfortable supplying your personal documents, personal information to get a more sort of personalized interaction with the AI model. All right, so we downloaded our Docker container. Now we're extracting it. In just a moment or two here, it should start up. The Docker run command, we can take this apart quickly. So we're going to publish the port 8080 from inside the container to port 3000 on our host. That's where we'll be accessing the container. We're attaching a volume for the Llama data. This is where the models and stuff will get stored. We're doing another volume for the OpenWebUI data, which is where we'll store things like the user authentication and any data that's generated while interacting with the front end, giving a name to the container, asking Docker to always restart it if it were to stop for some reason or if our system were rebooted. And then finally, we just have the path to the image, OpenWebUI with the integrated Llama frontend. And we're also using daemon mode, so it will run in the background. So our image is running, and with that, so I just need port 3000 at our WireGuard IP, so I can use this IP. And port 3000, there it is. This
You
will
made
open. Yeah, it worked. Okay, I'm not authorized, but that's just because I was using some leftovers from last time. If you're coming into a fresh deployment and you haven't done this before, then you won't see an unauthorized error. This part, it's actually, when I first saw this, I was like, what? I have to log in? But really what we're doing is just creating an account in our local instance. So if you read this, it's saying OpenWebUI does not make any external connections. This is just authenticating ourselves into our own server, and this email address and password is stored locally. You can type whatever you want to into here. OpenWebUI has the ability to do a multi-user setup though. So when you sign in when you make this first account, you become the admin, but you can do a multi-user setup in here if you wanted to share this with some friends or something like that. And you do have that option. Oh, what did I do here? Just click on the wrong thing there. Okay.
We can see now.
Zoom. All right, great. Okay, so here is the interface. Things seems off here. We're just seeing a black box. Which something happened with the screen sharing.
But on our end, we can see well.
Yeah, it's weird. I just have a black box on my screen. Interesting. Anyway, I will continue here. Hopefully this won't get in my way too much, although I think it will because I need to be able to click right here. Well, let's see how far I can get this. Okay, so inside Open WebUI, if I come in here to the admin panel, then I can come here to models, and you'll see there's a models selector up here at the top. And if you go in there, you won't find any models by default. So this, in order to load a model, what we need to do is come in here and enter the model tag here. So here we can enter any tag that we found before on the Llama library. So we could use like this tag, Llama 3, 8 billion, and it's actually the default, so all we need to type is Llama 3. But we could also use any other tag from any other model that's in here. So we just write the model tag and hit the little download button here, and it will start to download the model. Again, it's about 4 gigabytes, so it's going to take a minute. And while that's happening, I'm going to see if I can get rid of this annoying black bar. Give me just a moment. All right, there we go. It's gone. These are the joys of being a desktop Linux user. Do appreciate that Zoom is available, of course. Weird things can happen sometimes. All right, so, well, I could actually be showing you around the interface here while this is downloading. What I found for best results when downloading these models is just stick here on the page until it's finished and let it do its full thing. It does take a bit of time to download some of this data, but overall, it's not bad. I mean, if you consider that we are getting an advanced AI that we can talk to in our own web browser here, and it's taking 10 or 15 minutes to set up, and overall, I'd say it's not bad. So download is complete. It's going to take a minute here to verify. One thing I like to do actually is just run top in my terminal, and this can, this Open Web UI is pretty good, but it's under heavy development, and it doesn't always do a great job of telling you about like what's going on. So here we can see like Llama is definitely working, and what is it doing? It is verifying that this image is downloaded correctly. One thing that's kind of interesting is these Llama images, they use sort of a similar style as Docker, so they might even use Docker, I'm not sure. So the way that the tags work and there's layers and things like this should feel very familiar if you know anything about Docker. So now we can see we have our model here. That's nice. This is actually the menu to delete, but we'll do that now. There's some other features in here, like if we put some documents inside of the documents folder, we could scan those. We can enable web search with the search engine here. There's some options around the interface. This is title generation. You'll see it actually uses the model to generate a title for the conversations that are happening. And there's some other stuff in here. You can actually link up like an image generation This is like stable diffuse, like a local self-hosted stable diffusion. You can link that up and like get images inside your chat. So that's kind of interesting. Anyway, let's come back to the main interface here. So I will select a model and set this as the default. And let's have it tell us a fun fact about the Roman Empire. I've done a few of these already, and they are indeed fun. I'm not sure if the facts are actually true. That's something that you always have to be careful about with large language models. They will very confidently tell you things that are completely wrong. But hey, it's fun. Ancient Rome is considered good luck to bring home a wild boar forest tied to your front door. Ward off evil spirits and misfortunes. Oh, quite interesting. So as we can see, like with 16 CPU cores, the performance is pretty good. And we can ask questions about ancient Rome, and the model seems to know some things about it, which is cool. And here it's generated a title over here. So that was fun. Let's try another question. We might be wondering about what's happening in our VM here and see if we can get some help. So please write a shell command to containers. And let's see what it comes up with.
This is so cool.
Yeah, these actually work. These are actually real shell commands that I could type into the terminal right now. Um,
Can you ask a question on ThreeFold?
like a technical question?
Yeah. Would it work?
Well, that's a good question. I have one more example that I'll show that is
All
threefold
right, all right.
related. One thing I've found with Llama 3 is that it can tend to be rather verbose. Like I just asked for the shell command, it's giving me a lot of extra info, which is cool. I mean, this is more or less correct, and it works, and it's even giving us a warning here, so that's kind of cool. I won't run those commands now, but we could do that later. So here's another one that I thought was fun. So if you don't want to give you quite so much information, we can say please synchronize. So it looks like market outlook is good for cloud computing according to the AI, and maybe we'll let it roll for this one.
It's still being nice to you, Scott. I once had a stand-up comedian say, I'm going to summarize my show in one sentence, and it took him 10 minutes to finish the one sentence with a lot of commas in it. So you're still lucky.
Oh, yeah. Yeah, Llama 3 is known for being nice, actually. Yeah, I haven't had the self-hosted AI models turn on me yet, but you never know what can happen. So now I'm asking about a decentralized autonomous cloud solution, and Llama seems familiar enough with this to even give it an acronym, which is interesting. Could be a game changer in the cloud market, potentially disrupting traditionalized centralized cloud models. It's going to go on and tell us a number of things about clouds that actually sound very convincing. I mean, I would say that this AI is fairly smart, or at least it seems to be fairly smart. Yeah, and it comes up with a lot of actually the benefits that we talk about in our threefold materials, which is interesting, like edge computing, new market opportunities, and users create their spare space, and things like this. So this is kind of fun. It's, we're able to converse with it and ask it some questions. It's able to give us some pretty interesting answers. Should we ask another question about threefold specifically? What do you have in mind, Mik?
Maybe just summarize the ThreeFold project.
Should we say threefold cloud or something?
Yeah.
Threefold Foundation, nonprofit organization, centralized community-driven internet infrastructure. Platform combines blockchain technology, artificial intelligence, and cloud computing. Well, I guess we're doing artificial intelligence now, so.
Updated live.
Yeah.
So one thing interesting there is on the page we're looking at the bottom, LLMs can make mistakes, very important information. I think that's important to stress out. So use this carefully and always doubt maybe what you're reading and check for yourself before maybe taking a important decision. So one thing is, if you ask the AI, it's always certain of what it's saying. It's if you ask a question that it doesn't know, it will just write stuff. So it will be very sure of what it's saying, but it's completely wrong. So just something to take in mind.
Absolutely. Yeah, that's something I found in my own interactions with AI is that sometimes it is absolutely right and sometimes it is absolutely wrong, and it's just as confident in either case. I mean, that's one of the things, well-known things about large language models, and something that they're trying to work on making these things be a bit more
So
aware of what they don't know.
for example, on here it says artificial intelligence. It says that the threefold grid uses AI to optimize node performance, but that's not the case. So it just invents stuff when it doesn't have all the information. So it's just something to keep in mind. And actually, when you want to use this type of technology, you can train it. Maybe we could explore this in another session, but you can train it on your documentation. So let's say you could take this Llama tree and train it on the ThreeFold website and the ThreeFold documentation, and then it could be used accurately to answer questions for users.
Absolutely. Yeah. So we can submit websites here. I experimented with that a bit. I found it wasn't like didn't quite give the results I was hoping for. But I think with a more involved training approach, definitely you can get more targeted information. Also, I'll show here like we can upload a file. So if I had some file that I wanted the model to look at, I can upload it and I can ask it to summarize the file or get the key points or whatever, and it will do that. It will take a bit more time than these sorts of queries I was showing here, but it's something that's certainly possible. So, all right, that's the demo.
So thanks everyone for joining us, and we will announce shortly in the coming days or the next subject for the next demo session. So thanks a lot for being here, and see you next time.
Yep, thanks everyone. Bye.
Thank you, Scott. Thank you, Mik.
You guys.
Thanks, Cameron.